Hello, my name is Daniel Gonzalez. For my senior project, I was working on Virtual Labs 7.0. My team members were Crystal Rivera, Juan Riaño, Johan Henao, and Trung No. In the past, Virtual Labs has been implemented using VMware. VMware is a proprietary solution that allows for the creation of virtual machines. However, VMware is less reliable than the alternative KVM. Because of this, we have decided to switch from VMware to kernel-based virtual machine, or KVM. KVM is also an open source solution. The problem then lies in that the virtual clusters must be made to support KVM. This includes updating any previous scripts and software. This Gantt chart shows my progress from converting the VMware solution to the KVM solution. The use cases implemented were starting a VLabs, stopping a VLabs, destroying a VLabs, the use of control buttons. This means starting a virtual machine, stopping a virtual machine, rebooting a virtual machine, suspending or saving a virtual machine, refreshing a virtual machine, and automating the conversion process. In the use case diagram, you can see that the FIU student has the ability to start a VLabs, their own VLabs, stop a VLabs, or use the control buttons. An admin can start, stop, use the control buttons, or destroy any number of VLabs. The first sequence diagram shows how a user can start a VLab. The user, starting on the VLabs main menu, clicks on Start VLabs. The main menu sends the data to the UI controller, which then sends the data to the Start VLabs controller. The Start VLabs controller sends data to storage, saving its status, and then it sends the data to the Start VLabs script, which ultimately starts the virtual labs. The UI controller also displays the VLabs login page. The second sequence diagram shows on stopping a VLabs. It is essentially the same as starting a VLabs. The third sequence diagram displays how to destroy a user. The admin in the admin's page demotes a user. This sends the message to destroy the VLabs. As you can see, there is no display script. Our system uses a three-tier architecture. The user interface is basically eFront. In the logic tier, eFront communicates with the jQuery UI that was created by Crystal, Trung, and Johan. This communicates with the many Virtual Labs Java programs. The Java programs send the data to the SQL database, and they also tell the VM management what to do. The VM management is the scripts to start, stop, destroy, or otherwise modify the VMs. The hardware requirements are a computer with 64 gigabytes of RAM, 1.5 terabytes of storage, and 2.4 gigahertz CPU 6 cores, all running on a Linux kernel of CentOS. The software requirements are Python 2.6 with PXSSH installed, Nmap, KVM, and libvirt. All persistent data for KVM is stored in flat files. These are the VMs, and if the VMs have a saved state, these will be saved directly in the virtual cluster storage. All the other persistent data is stored in the SQL database mentioned earlier. This data is only used to interact with KVM. KVM does not modify, store, or otherwise erase this data. KVM's hypervisor, which is QEMU system, only allows for the virtual machines en route. When a virtual machine is created or used, it automatically becomes the property of the root user. However, by using PolKit, the portal user can have access to KVM. Other than this, there is standard Linux security. This class diagram is for the virtual machine management. As you can see, it has all the commands needed by KVM to run the virtual environment. Start virtual environment, start VE, start a virtual machine. The start virtual environment is dependent on the start virtual machine. There is also provisioner and is RDP ready. Start VE is again dependent on these. Stop VE is dependent of stop VM, and stop VE stops the virtual environment. Run VM commands contain the commands start, stop, reboot, and get state. Refresh VE has not yet been implemented, but it will rely on refresh VM, which is implemented and refreshes the VMs. This means it completely destroys the VM and then restores it. This is a state machine diagram displaying start VE. First start VE is called. Then we are in the beginning state. If it recognizes an incorrect amount of inputs, it will finish its state. It will exit with an error status. When it has the correct inputs, it checks if it's been provisioned. If it needs provisioning, it provisions. Once it's done provisioning, it goes to the start VM. If it does not need provisioning, it also goes to the start VM. Start VM begins, and RDP generally is not ready, so it will wait for the RDP. This will also wait for the RDP until the RDP is ready. Once the RDP is ready, it will start the next VM, going back. This will continue until there are no more VMs. Once the final VM has RDP ready, or remote desktop protocol, it will go to its final state. This is a sunny day test case to see if VLabs will start with the expected inputs. As administrator, you have to log into Portal in Virtual Cluster 7. StartVE.py is the script that will start the virtual environment. iCard005 test, the next input is the name. K26 is the version that is being run of Virtual Labs. 50501 is the port number. The next number 5 signifies that there are 5 ports. 12233 generates the MAC addresses. There are 6 MAC addresses. 1 is the router to be started. 7 signifies that we are in Virtual Cluster 7, and 0 means that it needs provisioning. The expected output is that a virtual environment for iCard005 test will begin, and the actual output is actually the same as the expected output. The purpose of this rainy day test case was to see if Virtual Labs would start with the expected inputs. However, in this case, the virtual machines have first been started and then stopped, meaning their status has been manually stopped. As the setup, you need to log into Portal in Virtual Cluster 7 and manually stop the virtual machines first. Use the same test inputs as before. The expected output is that a virtual machine for iCard005 test will begin again. However, the actual output was that the virtual machines would not begin. This needed to be corrected. Now I will show you a quick tech demo of the virtual labs implementing KVM. This is a tech demo of the KVM implementation of virtual labs. To begin with, I sign in with my KVM test name. Next, I click on Virtual Labs. Once it's begun, it takes a few seconds, but then it begins to load all the virtual machines. As you can see, Router 1 has started. The first virtual machine for Domain Controller has also started. These will keep popping up fairly frequently. Once all have been loaded, we click on Domain Controller link. However, in this implementation there was a slight problem with the Domain Controller in that it wasn't recognizing the username. Because of this, we can use the refresh button. Now refreshing takes a while, so I've sped this video up by 5 times its normal percentage. As you can see, it takes quite a bit of time, even sped up. However, after a few seconds, we log on again. This had to be done for the workstations as well. Once this was done, we tested each virtual machine to make sure they were running. Afterwards, we ejected, stopping the virtual machines. This has been a tech demo of Virtual Labs implementing KVM. Thank you.